As measurements. So it's an example. It's 2 1/3 miles from Mia's house to the 7-Eleven. Okay? I'm thinking of the number here as a measurement, as a distance. You know, it's something I'd have to measure. Okay? Here's the thing you can't do enough of with your students. Starting in kinder, having them measure things. One of the things that you need to have in your classroom, and I know Lorenzo's done this several times with our irrational number folks. One, you need number lines up in your room. Every one of your teachers, everyone in your school, you know, everybody, Maxine, should have a number line. And not just a number line with whole numbers, number lines with fractions on them, and number lines with negative numbers on them. Remember those cool vertical number lines that you got a few years ago? Most of you guys have those now. Okay? That's one thing. Here's another thing you have to have in your room, and you have to have lots of them. Rulers, including centimeter rulers and measuring sticks. You want to be super cool. Okay, not just yardsticks, meter sticks. Okay, meter sticks. And measuring tapes. Lots of measuring tapes. Okay? Kids should be measuring all the time. All the time. They can't do enough of it. So we know, New Mexico, you know, on the test, one of the areas kids consistently fall short is measurement. So notice I didn't state this as a problem, right? It's just, you know, it's a distance. But here's a problem. Find two fractions between 3/6 and 4/6. This is a measurement problem because I'm thinking between. I have to think about numbers and finding other numbers between others. That's a measurement way. It's a distance sort of notion, so it falls under measurement. That's another way to think about fraction. I have to be able to identify fractions between fractions, or distances between numbers and that type of thing. Okay? Here's a really cool idea. And I'm going to get at with a question. How many fractions are there between 3/6 and 4/6 on the number line? So it looks to me like this is a finite distance, right? I could take out a ruler right now and I could measure that distance. Okay? I could measure it. I don't know, maybe it's 2.5 inches or 3 inches, whatever, you know. There's some finite distance. So there must be a finite number of fractions between those two numbers, right? No. No? How many are there then? Like 100? 150? Infinite. Wow. Okay. So a lot of you already pointed it out. In that red area there's an infinite number of fractions. I mean, so I could pick any two, you know, any two numbers. So we start with 2/6 and 3/6. You're telling me there's some fraction between them? Do you agree with that? Here, I'll design one right now. How about 2 1/4 sixths? I'm claiming that's between the two. Is that okay? I can convert that into some number, can I? I could. Is that hurting your brain right now?
It's like the Zeno's paradox.
Okay, okay. We could keep playing with, okay, what does Zeno's paradox say?
When you're halving the distance.
Halving the distance.
Halving?
Uh-huh.
You're cutting the distance in half. But there's an infinite number of halves between. Yeah. That you could never actually get to the point where...
You want to model it for us right now? Okay.
That's what we've done in my class.
You've done Zeno's?
Yeah, we've had that in my class
Okay.
where we were walking across, walk halfway, then halfway, then halfway.
Did we do that one together?
I don't know if we did or not.
Okay.
No, there was a video that you showed.
Oh, that's right. I showed you the Zeno's paradox. Yeah, that some of my students designed. Oh, yeah. Right. Right, with the whole, yeah, okay. So, so we can keep going. So, okay, the idea, let's just model it for those of us who don't know it. I want to walk from this wall to that wall. And the question is, will I ever get there if I always have to stop halfway? So like right now, I'm going to go halfway from this wall to this wall. Okay? But I always have to stop halfway. So now I'm going to go from here to the wall again. But I'm only going to go halfway. Okay, if I keep repeating this, will I ever get to the wall? Will I ever get there? I mean, I get really close, right? So there's halfway again. I'm getting pretty close already. Halfway again. 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 I'm getting exhausted. Halfway again. Am I ever going to get there? So the idea being that there's always some little distance I can go if I'm going halfway. So there's always a fraction. Yeah, isn't that cool? Yeah. So it's called the density. The density of my brain. No, the density of the rational numbers. Okay? They're dense, man. The density of the rationals. It's really cool, huh? This idea that there's an infinite number of rational numbers, fractions, between any two that we start with. That's pretty cool. By the way, rational number fraction is pretty synonymous. Some people would say they're not exactly the same. I usually just use them as synonyms. It's just easier. Are we doing okay? All right, somebody give us the 5 fractions that we just learned about. 5 ways to think about fractions. Somebody, without looking in your notes. Come on. Catherine, can you do it? Okay, fractions are operators. Somebody else. A second one. Ratios. Say it again. Part to whole. Quotient. We got one more to go. Measurements. Okay. How many, come on, confession time. How many of you do part whole and you don't think about the other ones? Probably a lot. See? And just so you know, that's common. I'm challenging you today. Here's the fraction challenge. So we could be the fraction faction. You ready? Okay? Measurement, you need to do more. Get out those measuring tapes. Do lots of measurement. You're going to do more with quotients now. Quotients, partitioning, right? Just think quotients, partitioning, dividing stuff up. Okay? You're going to do more with operators. Lorenzo is 5/6 as tall as Casey. That comparison kind of thing. Comparing. Okay? And ratios, part. You good?